In a small apartment in Stockholm in 1878, a 17-year-old student accidentally shattered a glass tube containing a mysterious mineral sample he was analyzing, and in his frustration at the broken equipment and ruined experiment, he noticed something extraordinary about the fragments scattered across his makeshift laboratory bench, a faint greenish glow that should not have been there, a phosphorescence that would lead him to discover not one but two previously unknown chemical elements and launch a scientific career that would revolutionize our understanding of atomic structure, radioactivity, and the periodic table itself. This accidental discovery by a teenager working in primitive conditions with borrowed equipment would ultimately contribute to technologies ranging from cancer treatment to nuclear energy, yet his name remains largely forgotten outside specialized scientific circles despite discoveries that earned multiple Nobel nominations and transformed modern chemistry. This is the remarkable story of Per Teodor Cleve, the Swedish chemist who discovered the rare earth elements holmium and thulium while still a teenager, demonstrating that groundbreaking scientific discovery requires not expensive laboratories or advanced degrees but rather keen observation, intellectual curiosity, and the wisdom to recognize significance in unexpected results. Born on February 10, 1840, in Stockholm, Sweden, Per Teodor Cleve grew up during a period of rapid scientific advancement when chemistry was evolving from medieval alchemy into a rigorous discipline based on atomic theory and systematic experimentation. His father worked as a gardener at the royal palace, providing a modest but stable income that allowed Per Teodor to attend school and develop his early fascination with the natural world and particularly with minerals and their chemical properties. Young Cleve displayed exceptional aptitude for mathematics and science, spending hours studying rock samples he collected around Stockholm, attempting to identify their composition through simple tests he learned from library books. At age 15, Cleve enrolled at Uppsala University, one of Europe's oldest and most prestigious institutions, where he began formal study of chemistry under the guidance of renowned professors who recognized his unusual talent for analytical chemistry and systematic investigation. The 1850s represented a revolutionary period in chemistry as scientists worked to organize known elements into coherent systems that would eventually become the modern periodic table, with particular focus on the rare earth elements, a group of chemically similar metals that were extraordinarily difficult to separate and identify. Cleve became obsessed with rare earth chemistry during his undergraduate years, recognizing that these poorly understood elements held secrets about atomic structure and chemical bonding that could reshape the entire field. He set up a modest laboratory in his apartment, using equipment he borrowed, built himself, or purchased with money earned through tutoring, conducting experiments late into the night when he should have been sleeping or studying for examinations. His professors worried that this obsessive focus on a single narrow topic might damage his broader education, but they could not deny the sophistication of his experimental techniques and the rigor of his analytical methods. The rare earth elements presented unique challenges because they occurred together in mineral deposits and had such similar chemical properties that separating them required hundreds or even thousands of repeated crystallization and precipitation steps. Most chemists considered rare earth research tedious and unrewarding, but Cleve possessed both the patience for repetitive work and the intellectual insight to design systematic separation schemes that gradually isolated individual elements from complex mixtures. In 1878, while still completing his doctoral studies, Cleve obtained samples of a mineral called ERBIA, a complex oxide containing multiple rare earth elements that had been partially analyzed by other chemists but never completely separated into its constituent parts. He began a painstaking process of fractional crystallization, dissolving the oxide in acid, precipitating specific fractions, dissolving and precipitating again, repeating the process hundreds of times while carefully observing changes in the chemical properties and spectral characteristics of each fraction. During one late-night experiment, Cleve was preparing to analyze a particular fraction when he accidentally dropped the glass tube containing the solution, shattering it across his laboratory bench. Frustrated and exhausted, he began cleaning up the broken glass and spilled solution, but in the dim lamplight, he noticed something unexpected. Some of the glass fragments were glowing with a faint greenish phosphorescence that intensified when he moved them near the flame of his lamp. This luminescence should not have existed in the compounds he thought he was working with, suggesting the presence of an unknown substance with unusual optical properties. Rather than dismissing this observation as a contamination or experimental error, Cleve recognized it as potentially significant and began systematic investigation of what was causing the unexpected glow. He carefully collected the spilled material, repeated his separation procedures with even greater care, and discovered that he could isolate two distinct fractions with different spectroscopic signatures, different chemical behaviors, and different luminescent properties. If you find these stories of accidental discoveries that changed science inspiring, stories of young researchers whose keen observation and intellectual courage led to revolutionary breakthroughs, consider subscribing to Hidden Minds and activating the notification bell to explore more extraordinary moments when unexpected results revealed hidden truths about our universe. Through meticulous spectroscopic analysis, Cleve determined that these fractions contained previously unknown elements, substances that had been hidden within the ERBIA samples because their chemical similarity to known rare earths made them impossible to detect without the precise separation techniques he had developed. He named the first element Holmium after Holmia, the Latin name for Stockholm, and the second Thulium after Thule, the ancient name for Scandinavia, asserting Swedish priority in their discovery and honoring his homeland. The announcement of these discoveries in 1879, when Cleve was only 19 years old, created immediate controversy in the scientific community. Some established chemists questioned whether a teenager working in a makeshift apartment laboratory could have made discoveries that had eluded well-funded researchers in major institutions across Europe. Others suggested that Cleve had merely rediscovered elements that had been previously identified, but not properly characterized, attempting to diminish his achievement through claims of prior discovery. Cleve responded by providing detailed spectroscopic data, careful documentation of his separation procedures, and samples of the purified elements that other chemists could analyze independently, demonstrating scientific rigor that silenced most critics. His work was particularly significant because it came just as Dmitry Mendeleev was refining his periodic table, and the discovery of Holmium and Thulium provided crucial data points that helped validate Mendeleev's predictions about undiscovered elements and their properties. The discovery established Cleve's reputation as one of Europe's leading analytical chemists despite his youth, and he received his doctorate from Uppsala in 1863, then was appointed to the faculty where he would spend his entire career conducting groundbreaking research in inorganic chemistry and mineralogy. His techniques for separating rare earth elements became standard methods used by chemists worldwide, and his spectroscopic analyses contributed to the development of more sophisticated instruments for identifying chemical composition. Beyond his teenage discoveries, Cleve made numerous other significant contributions to chemistry throughout his career. He conducted important research on scandium, another rare earth element, confirming its properties and position in the periodic table. He investigated the chemistry of platinum group metals, developing new methods for purifying and analyzing these valuable materials. He studied the composition of Swedish minerals, cataloging their chemical content and contributing to both theoretical chemistry and practical mining industry applications. Cleve also became an influential educator, training generations of Swedish chemists and establishing Uppsala as a major center for analytical chemistry research. His teaching emphasized careful experimental technique, systematic observation, and the importance of pursuing unexpected results rather than ignoring data that did not fit preconceived theories, lessons drawn from his own accidental discovery of holmium and thulium. Despite these achievements, Cleve never received the Nobel Prize, though he was nominated multiple times and certainly deserved recognition for discoveries that fundamentally advanced chemistry. Some historians suggest that his work on rare earths, while scientifically significant, lacked the dramatic impact or broad applications that Nobel committees tended to favor, while others note that his discoveries came before the Nobel Prize was established in 1901, meaning his most groundbreaking work was already historical rather than recent when awards began. The rare earth elements Cleve discovered have proven far more important to modern technology than anyone in the 19th century could have imagined. Holmium has unique magnetic properties that make it valuable in nuclear reactors, lasers, and medical devices, while thulium finds applications in portable X-ray machines, surgical lasers, and advanced materials science. The global rare earth industry generates billions of dollars annually, and many modern technologies from smartphones to electric vehicles depend on rare earth elements, including those Cleve was first to identify and characterize. Per Teodor Cleve died on June 18, 1905, at age 65, having spent his entire professional life at Uppsala University, where he had first studied chemistry as an ambitious teenager. His funeral was attended by prominent scientists from across Europe, and obituaries recognized his contributions to analytical chemistry and rare earth research, yet his name gradually faded from popular memory as newer discoveries and more recent Nobel laureates captured public attention. The story of his accidental discovery while cleaning up a broken experiment has mostly been forgotten, replaced in chemistry textbooks by dry descriptions of rare earth properties and periodic table positions that give no sense of the human drama behind scientific discovery. Students learn about holmium and thulium without knowing they were discovered by a teenager in a makeshift apartment laboratory who recognized significance in an unexpected glow from broken glass fragments. Cleve's story embodies several important truths about scientific discovery that challenge common assumptions about how breakthrough research occurs. First, it demonstrates that major discoveries can happen anywhere, not just in prestigious, well-funded laboratories, and that sometimes limited resources force creative approaches that reveal things conventional methods might miss. Second, it shows the critical importance of observation and intellectual curiosity, as Cleve's discovery depended entirely on his decision to investigate an unexpected phenomenon rather than dismissing it as irrelevant contamination. Third, it reveals that accident and serendipity play larger roles in scientific progress than the sanitized versions in textbooks acknowledge, with chance observations by prepared minds often proving more valuable than carefully planned systematic investigations. The fact that a 17-year-old could discover new chemical elements while working in primitive conditions should inspire young scientists today, demonstrating that age and institutional affiliation matter less than careful observation, systematic methodology, and willingness to pursue unexpected results. Cleve did not have access to modern instrumentation, computer analysis, or sophisticated laboratory facilities, yet his discoveries remain valid and significant over a century and a half later because they were based on rigorous experimental work and careful reasoning. Modern chemistry students working with advanced spectroscopic equipment and computational tools might reflect on how Cleve achieved his results using only simple glassware, flame spectroscopy, and meticulous repetition of crystallization procedures. His techniques for separating chemically similar elements through fractional crystallization remain fundamentally sound and are still taught as classical analytical methods, though modern chemists can accomplish in hours what took Cleve months of patient work. The technologies enabled by rare earth elements, from the powerful magnets in electric vehicles to the phosphors in display screens to the lasers in medical devices, all trace back to 19th-century discoveries by chemists like Cleve who patiently worked to identify and characterize these unusual materials. Every time you use a smartphone, watch a modern television, or benefit from advanced medical imaging, you rely on rare earth elements whose very existence was unknown until teenagers and young researchers made accidental discoveries that revealed new layers of chemical complexity. Per Teodor Cleve discovered holmium and thulium by accident while still a teenager, demonstrating that groundbreaking science requires not advanced degrees or expensive equipment but rather careful observation, systematic investigation, and intellectual courage to pursue unexpected results wherever they lead. His story challenges the myth of discovery as a process of genius individuals working in isolation, revealing instead that major breakthroughs often come from patient systematic work interrupted by fortunate accidents that prepared minds recognize as significant. Perhaps the greatest lesson from Cleve's teenage discovery is that the next major scientific breakthrough might come from anywhere, from anyone willing to look carefully at the world, question assumptions, and investigate phenomena that others dismiss as irrelevant, reminding us that scientific genius lies not in credentials or resources but in curiosity, observation, and the wisdom to recognize importance in the unexpected.